Okay, so this is for anyone that needs a little warm up on or revision for writing equations according to the type of reaction and balancing them. So we are going to start with what do these mean. So this is my acronym for metal plus oxygen gives you a metal oxide. And for this, we are going to be able to have to write a formula from a name. The men wear many hats hopelessly is the silly sentence for this, and it is a metal plus water gives you a metal hydroxide and hydrogen gas. Now, for this, we need to know how, again, to write a formula from a name. And just to remind you that hydroxide is a complex ion. So in this one, the group 1 metals that we are going to look at are going to be, let me find the ones I decided on, potassium and rubidium from group 1, and from group 2 we're going to do beryllium and radon. So we're going to start with MOMO, and we're going to start with potassium. So the word equation, which you would have to finish in ordinary level, but in higher level it will be straight into the chemical or the formula equation, gives me potassium oxide. So for potassium oxide, we have to know that potassium is in group 1. It has a valency of 1, so it gets a +1 charge. Oxygen is in group 6. It gets a valency of 2. And in our drop down, it is the numbers that we are interested in. Now, this is 1+, and the 1 is always inferred, as we've talked about. So when I drop down the number of the charge, I get a 2-to-1 ratio. So my formula for potassium oxide is K2O. So we go K plus O2 becomes K2O. And in the beginning balancing, I've asked you that when we're doing our balancing, you write out all the elements you have and you put them in your package. So when we look at this, we can look at the potassium, we can look at the oxygen, it doesn't really matter. If I look at the potassium, I need to have another potassium on my left-hand side of my arrow to give me 2 potassiums. Okay, so that solves my potassium problem, but it doesn't solve my oxygen problem. And my oxygen problem is I have 2 oxygens on this left-hand side, and I currently only have 1 here. So to get a second oxygen on my right-hand side, I have to put in the whole package. So doing that, I've now solved my oxygen problem, but my potassium problem is now still there. So I have to do that, I have to add 4 more potassiums. So to check that I'm right, 1, 2, 3, 4 potassiums versus 1, 2, 3, 4. 1, 2 oxygen versus 1, 2 oxygen. So the numbers that I'm writing in is 4K plus 2K2O. So that is MOMO for potassium. Now, the good news is once you have figured out one group 1 element, then the rules stay the same for everything else. So again, if we look at MOMO, we're looking at it for rubidium. Rubidium plus oxygen gives you rubidium oxide. And again, to work it out, I know rubidium is group 1 plus 1. I know oxygen is a 2-. It is the number of the charge that I'm interested in that we're going to drop down. So when I do that, it's still a 2:1, and now I have Rb2O. So once you figured out one group 1, everything else follows the exact same. So I'm going to do this as a speedy version. To get the same number of O2, if I put a 2 in front of my rubidium here, I then have 2 2s or 4 rubidium here. I am now balanced. So as you can see up here, the numbers in front are the exact same once you figured out what it is for group 1. So I'm going to do the men wear many hats hopelessly. For our group 1, I'm going to pick one of the elements. We're going to go with rubidium. So men wear many hats hopelessly is a metal plus water. So we'll do it for rubidium. Rubidium plus water is going to give me a metal hydroxide. So that's going to be rubidium hydroxide, and it's going to give me hydrogen gas. So again, we now need to be able to write rubidium hydroxide as a formula. So rubidium is easy because it's in group 1, but the OH minus, the hydroxide, is a complex ion. Keep asking you to learn them. It is really in your best interest to do it. We drop and we drop. It's going to be a 1:1. So when I'm writing my formulas, plus H2O becomes RbOH. If you wish, you can put it, because it's a complex ion, in brackets. The 1 is inferred, and hydrogen as it exists in nature is H2. So we go to our packets of stuff. So rubidium plus water gives me RbOH and HH. So in my head, the most obvious thing is I have 2 oxygens on my left-hand side, 3 oxygens on my right. If we were to go to 2 hydrogens on my left, 3 hydrogens on my right. If we were to go to 4 hydrogens, it would look like this. So if I go to 4 hydrogens here, I now have 2 O's on my right-hand side. So maybe if I go like this, it solves my problem. So am I done? I have 1, 2, 3, 4 hydrogens, 1, 2, 3, 4 hydrogens. I have 2 oxygens, 1, 2. I have 2 rubidiums, 1, 2. So I need to add another rubidium over here. And now I am perfectly balanced. So putting in my numbers, it's going to be a 2 rubidium is to 2 water is to 2 rubidium hydroxide is to 1 hydrogen. We are now balanced. We picked some group 2. So I'm going to do MOMO and beryllium for group 2. So beryllium, I don't know if that's spelled correctly, apologies if it's not, plus oxygen goes to beryllium. Yeah, I'm not sure if it's spelled correctly, oxide. So I now have to write a formula from a name. So beryllium is a group 2, 2 valence electrons. Oxygen is an O2 minus. Again, it is the number of the charge that we're interested in, not the charge. I'm not interested in any subscripts. So if they were subscripts, they'd be down here. We're not interested in any of those. So when we do this, it's a 2:2. And the rule, if it's a 2:2, it's actually a 1:1. So we write our equation, except it doesn't want to write. So Be plus O2 goes to BeO. So we again package up if we're not 100% confident on the packaging. So BeOO goes to BeO. So in my head, the thing that's screaming at me right now is I need to get 2 oxygens on my left and 2 oxygens on my right. And now I need another Be just to be safe. And I've got 1, 2 Be, 1, 2 Be, 1, 2 oxygen, 1, 2 oxygen. That is now done. So I have 2 Be plus O2 goes to 2 BeO. And again, if I want to do it for any other element, then that is an easy thing if they're in group 2, because they'll all match. So the last one I'm going to do is a men wear many hats hopelessly. Metal plus water becomes a metal hydroxide and hydrogen. I'm going to do this for calcium. So calcium plus water becomes calcium hydroxide plus hydrogen. So we have to write our formula from the name of calcium hydroxide. So we know calcium lives in group 2 is 2 plus. We now know that a hydroxyl ion is a -1. We do our drop down. It is going to be a 1:2. So when I write my formula, calcium plus H2O, apologies, that should be water, becomes 1 calcium to 2 OH minus. So we put it in brackets like so, plus H2 hydrogen gas. We package it all up. So CaHHO, CaOH, OH in a package. and HH in a package. So the most obvious thing to me is the fact that there's 2 oxygens on my right hand side and 4 H's. So if I do that, to get the left hand side to match, I have to put in another package of water. So we now just check 1, 2, 3, 4, 1, 2, 3, 4, 1020, 1020, 1 calcium, 1 calcium. So that is done. So we have 1 calcium plus 2 H2O plus CaOH twice plus H2. So they were MOMO, reactions of metals with water or metals with oxygen. So in form 5, we look at some other types of reactions. So I'm going to skip to the end and I'm going to go down here to magnesium plus hydrochloric acid. And my acronym for this is that it's a MASH reaction. So it's a metal plus an acid, gives me a salt, technically a metal salt. So whatever your metal is, a metal salt plus hydrogen gas. So if we now have magnesium and hydrochloric acid, we have learned that we're definitely making magnesium something. And we have learned that hydrochloric acid produces chlorides. And we're going to have hydrogen gas. So that is my MASH reaction as a word equation. We now have to put it into formula. So Mg plus HCl. We have to figure out magnesium chloride. So magnesium is group 2. Chloride is a group 7, so it's -1. We do our drop down like so. It's going to be 1:2. So I write this as MgCl2 plus hydrogen gas. We package everything up so it's MgClCl and it is HH. And now we look at our line. So the thing that I am seeing here is that I have 2 H's on my right hand side and 2 Cl's on my right hand side. So to make those match, I have to put another HCl on my left. And now we just do our check. So I have HH, HH, Cl, 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 and I just happen to have 1 magnesium and 1 magnesium. So my MASH reaction for magnesium and hydrochloric acid is 1 Mg plus 2 HCl becomes MgCl2 plus H2. So there are 3 metal reactions. So metal plus oxygen, a metal plus water, and a metal plus acid. So it leaves us then with some acid-base reactions. So my silly sentence for these is all boys sing well, but it's an acid. I don't know why it doesn't want to play. Acid plus base. No, it really does not want to play. Gives you a metal salt plus water. So that's all boys sing well. And then we have an all boys sing well bonus. And the bonus is when our base is a carbonate. So we're still going acid plus base. In this case, a carbonate. It's going to give me my metal salt. It's going to give me water. And it's going to make me bonus carbon dioxide. So it's really important that you recognize if my base is a carbonate, I'm getting carbon dioxide. So we have half our word equation done. Phosphoric acid plus sodium hydroxide is going to give me a metal salt, so it's going to be sodium something. And we have learned that phosphoric acid makes phosphate salts. So I'm going to make sodium phosphate and I'm going to make water. So phosphoric acid, you're either learning it or you can work it out. But we'll go with that, you've learned it from now. So H3PO4, sodium hydroxide. Okay, I'm going to take a step back. How would we work it out? Because I think maybe that might be helpful. So we know that acids are all H+. We know that phosphoric acid or phosphate is 3-. So we're now having to figure out our formula. So we're actually going to go backwards, and we know the number of the charge is the thing we're interested in. So I'm going to have 3 H pluses for every one phosphate. So when I write my formula, I would write it as H3PO4. Sodium hydroxide, we've done already, but we'll just check on it again. So sodium hydroxide is going to go over here on the very right, is an Na plus. My hydroxide is a -1 OH minus. We drop, it is a 1:1. So this is going to be NaOH. It's going to make me sodium phosphate. So sodium is a +1, phosphate, PO4, 3 minus. Okay, again, we've said we're interested in the number of the charge. We are not interested in this subscript. It is just the number on the charge. So it's going to be Na is going to be 3 equivalents and phosphate is going to be 1. So when I write my formula, it's going to look like, apologies, it's going to look like Na3PO4 plus H2O. So this may look very, 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 very big packages of things, but needs must. So we go Na, POOO for our 4s, and we have HHO for our water. So we look at it. I am going to need definitely on this left-hand side 3 NaOHs because I have at least 3 on the right. So we now have 1, 2, 3, 4, 5, 6 H's on my left, whereas I only have 2 on my right. So let's see if I put HHO, will this work? So let's just do some ticking off to see. So I have 1, 2, 3, 4, 5, 6 H's. 1, 2, 3, 4, 5, 6 H's. My POO4 hasn't changed, so we'll just get rid of those. My Na, 1, 2, 3, 1, 2, 3. And I'm now left with the O from the OH, 1, 2, 3, 1, 2, 3. So we are now balanced. So I have 1 H3PO4, I have 3 NaOH, I have 1 Na3PO4, and I have 3 H2O. So you got to go slow and steady. And in that example, we had to do name from formula for sodium phosphate. We had to do name from formula for sodium hydroxide, formula from name, and we had to do it for phosphoric acid. So for phosphoric acid, as we say, you have to recognize that the acid portion is a H plus and the phosphoric part is your phosphate. So again, complex ions, you need to know them, make them your friend. So the last one that we're going to look at is sulfuric acid and calcium carbonate. You need to recognize this is an all boys sing well bonus. So an acid and a base, and our base is a carbonate. And it's going to give us salt and water. So again, our salt is going to be a metal salt. So it's going to be a calcium something. And we've learned that sulfuric acid gives you sulfate salts. So it's going to be calcium sulfate plus water. And our bonus thing, because it's a carbonate, is going to be carbon dioxide. Okay, so that's what the bonus part of this acid-base type reaction is. We're making carbon dioxide. So sulfuric acid, we know that the acid portion is H plus. You have to know your complex ion, sulfate, what is its formula? So we have H plus, sulfate is SO4 2 minus. We are going to do our drop, and we've said that it's the number that we are interested in. So it's going to drop as a 2 and a 1. So my formula for sulfuric acid is H2SO4. For my calcium carbonate, calcium is 2 plus, carbonate is a complex ion, so again, one you have to know, CO3 2 minus. It is the numbers we are interested in. When we do our drops, it becomes a 2:2, which is the same as a 1:1. So my formula for calcium carbonate is CaCO3. We have said it's going to make us calcium sulfate. So calcium is 2 plus. We've already learned that sulfate is SO4 2 minus. We drop a 2 and a 2, which becomes a 1 and a 1. So our calcium sulfate is going to be CaSO4 plus water plus carbon dioxide. So we package everything up. HHS 1, 2, 3, 4 O's in a package. Ca, C, 3 oxygens in a package. Ca, SO4, so 1, 2, 3, 4 in a package. HHO in a package and COO in a package. So we have 2 hydrogens on the left, 2 hydrogens on the right. We have 1, 2, 3, 4, 5, 6, 7 on the left of oxygen. We have 1, 2, 3, 4, 5, 6, 7 on the right. We have 1S. My gut is saying that we are balanced. I'm just going to cross it off just so we can check. So HH, HH, SO4, SO4, 1 calcium, 1 calcium. I have a carbon, I have 3 oxygens, 3 oxygens. So this particular equation is balanced as it is. I don't need to make any amendments to it. So there lies an introduction or a reminder on how to write word equations using the acronyms or the silly sentences. And we've learned that how we should balance. So we can do now MOMO, we can do metal plus water, we can do mash reactions. So there's 3 for metals. We can do a regular acid-base reaction, and we can do an acid-base reaction when we have our base as a carbonate. Thank you for watching.